Hi everyone, my name is Jennifer Fang, and today I'll be presenting on Adversarial Text Playground, which is my senior research capstone project. I worked with G and Professor Chi on this throughout the past year, and I'm really excited to tell you guys what it's all about. So, Adversarial Text Playground is a tool for visualizing adversarial attacks on text. So, the goal for this project was to develop a web visualization tool to educate people about adversarial attacks on text and also provide an extendable framework for other people to develop other visualization apps or kind of add to the framework that we already had. This project is based off of Andrew Norton's Adversarial Playground, which was a project that he did in his senior research capstone project. But his project was more focused on image-based inputs and didn't really allow for much extendability or adding to it afterwards. So the key features of this new adversarial text playground that we wanted to highlight were number 1, user-friendliness, number 2, visual aid, and number 3, extendability. So for user-friendliness, we wanted people to be able to use it even if they were beginners or if they were like really experienced programmers or if they were machine learning experts kind of but had less experience with software engineering. So to do this, we hosted Adversarial Text Playground on AWS Elastic Beanstalk, and we also added a lot of further documentation and explanations of algorithms. I think those are really important because having layman's terms of what algorithms do and how to use the site are all really important, especially for beginners. Otherwise, it's really hard for them to get invested and be interested in visualization. They might think that it's too difficult, too esoteric, and not be interested in it. For visual aids, we had a couple of really important features that we wanted to add. Number 1 was a heat map indicator to indicate which tokens of the text input sequence were most important, an importance highlighter to also show which parts of the sequence are most important, graphs for adversarial classifications, and also a highlighter to show which letters were perturbed from the original sequence to the adversarial sequence. And finally, extendability. There was a lot of refactoring and a lot of instructions in the README as well as in the code to help developers who want to add to this app or are having trouble hosting on Elastic Beanstalk to also add their code in. I think it's really cool and really easy to use to have an app that's hosted on Elastic Beanstalk, and I think that's also a direction that Professor Chi wants to move a lot of projects into. However, it's not the most intuitive process, especially because the documentation on AWS Elastic Beanstalk is a little bit sparse and also confusing at times. So having a lot of comments in the code and having instructions helps people be able to extend this project and use it in their project as well. So for a little bit of background on Adversarial Playground, it was a Flash web application that enabled users to visualize the creation of adversarial samples. In this picture shown on the right here, you can see that he's using his Jacobian saliency map approach. This was one of the algorithms that Andrew Norton was using for his project. And so on the right side, you can choose the seed image from the MNIST number data set. So it's pictures of numbers from 0 to 9. And he chose the number 3. So on the left is the original sample 3, and then on the right is the adversarial sample with some pixels changed a little bit to make it an adversarial sample. And so you can see from the highlighted red box that after going through the Jacobian saliency map adversarial algorithm on images, the target class was 1. And so now this adversarial sample, even though we can all kind of tell it looks like a 3 maybe, definitely doesn't look like a 1, it now becomes classified as a 1 in its target class. So this focus on visual inputs was something that Andrew Norton had because all of his algorithms related to that. But for our project, we wanted to accommodate text inputs as well as be able to accommodate possible other machine learning algorithms relating to like biomedical applications and etc. For the background of the deep word bug algorithm, this is something that G and Professor Chi have been working on for a very long time. And this is a black box approach on text input to create adversarial text sequences. So just as a basic overview, the parameters that G used in his model and that we were using for the adversarial text playground visualization are the model, power, scoring algorithm, and transformer algorithm. So the model describes the underlying data set. There's 7 of them, and they range from like news sites to Yelp ratings to Amazon ratings, etc. The power indicates the number of words being perturbed. The scoring algorithm picks up the top tokens and ranks them, and so there's multiple different types of them, including the random and gradient baseline algorithms. And finally, the transformer algorithm. So it describes how the word or how the resulting sequence will be affected and how it will be different from the original. So the homoglyph was the best performing one, and it swapped characters out for similar looking characters, but that were different UTF-8 characters that would cause the input to be different. So kind of like having the regular C and then the Cyrillic C. It looks almost exactly the same, but it's a completely different makes a completely different word and character. And there's also others like swapping letters, inserting letters, deleting, and substituting. And all of these parameters are things that the user will be able to control through the website and are explained very clearly and succinctly in the index page of the website. The hope is that by explaining all of these in very easy to use, friendly terms, the users will be able to interact with the visualization app very easily and will be able to kind of have more fun, play around with it, and understand more easily. And so now I'll do a demo of what we've been working on. So over here, you can see this is the actual visualization page, but the home page, it looks like this is the index page, and it has all different types of information that users can read, and it's a lot of background information that I think is not usually always accessible. I think a lot of times we've all had that moment where the README is very sparse and there's not a lot of guidance or direction. I think that's something that we really wanted to combat with this project, is make sure the users felt like they had all the information that they needed. So up here, this is the URL that anybody can use to access this adversarial text playground because it's hosted on Elastic Beanstalk. But here it describes the model, the power, the scoring algorithm, and the transformer algorithm all in more detail. And it also has a link to the paper and the source code, etc. if users want to learn more. But here is like very, very basic information that anybody who just is starting out can access. And so when you click on this tab for the deep word bug text sequence, this shows how to visualize what we've been working on. So the default input string is "I love watching sports like soccer," and it has a power of 2. The scoring algorithm and the transformer algorithm were chosen to be the best ones. And so clicking generate adversarial text sample yields something like this. The reason why AG News was chosen is because "I love watching sports like soccer" should be classified as obviously sports news. But by modifying with a homoglyph algorithm, the T turns into a slightly different looking T, and the C also turns into something slightly different. You can tell it's like a little bit skinnier and also a little bit narrower than the regular C. So all of this together makes the "I love watching sports like soccer" adversarial sample get classified as something in world news. So the second section is the original class and the adversarial class, and shows users what it's being classified as. And at the bottom, there's also a histogram of what the classifications originally were. So as you can see, originally, just with "I love sports like soccer," all with regular letters, the probability was around like 90-something% that it would be classified as a sports algorithm. However, after perturbing it, it became the highest was 34% for world news, which it probably is not world news, and it reduced down all the way down to around 11% for sports news. So you can see like what a dramatic impact this algorithm had. Moving forward to the kind of visual aids section, to read this sentence, all the words are the same font size except for sports and soccer. And so this is kind of our heat map importance indicator that I was talking about earlier. Basically, the top ranked token gets the biggest font size, and the second top ranked token gets the second biggest font size. And so users can automatically see and very easily see what are the most important words in this text sequence. And so they can tell also what is giving the most weight to the classification. And very intuitively this time, sports and soccer are the two most important words, and those contribute the most to making something either a sports classification or a world news classification. And so through this, users can really easily see something that's intuitive and say, oh, okay, this makes sense how this machine learning algorithm works. It separates out the tokens and ranks them. And I think ranking tokens is a kind of concept that is something that we all learned in like basic machine learning, but I think might be a little bit more hard or difficult for beginner users to grasp. But I think this creates a very, very easy way to visualize it. You just think, oh, okay, like soccer, the number 1 most important token, sports, the number 2 most important token. And that makes sense and kind of helps the user understand what's going on. The letters that are different in the perturbed sample. So with a power of 2, this is the number of words with characters modified, and the scoring algorithm and transformer algorithm, you just replace one letter. So 2 words, sports and soccer, were changed, and you can see the highlighting. The T was changed to a different T, and the C was changed to a different C. So this just helps be more obvious, because sometimes if you're changing kind of like the C to another C that looks almost exactly the same, it would be hard for users to see like the subtle differences, especially with the homoglyph algorithm, which is our highest performing one. Up on the top bar, these are the models, and so they're from 0 to 7, with model 4 being taken out, and each one represents something different. So all of these have explanations about Amazon plus minus is actually Amazon positive or negative, so it's a little bit less precise than the Amazon ratings from 1 to 5 stars, but something like this is all explained in the index page. So usually, there wouldn't be much explanation on things like this that I've seen in some apps, but because we decided to add a lot of text and a lot of background to the index page, this should all be very easy for users to understand. And so even the categories that are being generated are very intuitive. So like 5 stars, you can tell like, oh, okay, what does Amazon 1 to 5 mean? It's like a 5-star review, and everybody's been on Amazon and everyone's been on Yelp and stuff like that. So it's like very intuitive to understand what's being classified as like 1 stars, 5 stars, and what does that mean in the context. On the right is the kind of parameter control box, and so the first option is the input string with a default input string, so that users have a better idea of what they should start out with, especially if they're confused, don't know what kind of text sequence will work best. The second box is for generating the text sample. The third box is for power, which demonstrates how many words you want to be perturbed, and then the scoring algorithm with a drop-down menu, as well as the transformer algorithm also with a drop-down menu. So all in all, I think the controls should be pretty easy to use for anybody and also intuitive as to what they are. And finally, you can see how changing the model also changes what's important underlying in the text sequence. So for example, when we had I love watching sports like soccer run with AG News, the top rated tokens were sports and soccer, because it was classifying it into a category based on like the actual content. However, now that we're on Amazon plus or minus positive or negative review, you can see that the top rated tokens are love and like, which makes sense because love is a very positive word, and that would contribute to something being rated as positive or negative. And so you can see down here, like love originally had like a 91% of being categorized as a positive review due to this, but after changing the L to a slightly different L and the K to a slightly different K, you can see that negative and positive are 54 to 46. So, and then this ends up being classified as a negative review. So this is really powerful, and it can show you how changing the model and playing around with things makes everything a little bit different. I think there's a lot of different combinations for users to work through, a lot of different things for them to kind of play around with, and being able to toggle things really easily like this and kind of change things like this is something that's really conducive to helping users play with this like they're at a playground, which I think was the original goal of Andrew Norton, to make this adversarial playground very interactive as well as very educational. Finally, to discuss the implementation of what I've been doing through all this, so the first thing I wanted to talk about was hosting adversarial playground text on AWS. So I hosted it on AWS Elastic Beanstalk, and I think this is a really easy to use framework because through the Elastic Beanstalk dashboard, you can control lower level resources like partitioning, what EC2 instance you want to do, all through the Elastic Beanstalk dashboard. And it's kind of like an easy GUI format, and it's pretty intuitive, easy to use. However, there were some issues that I ran into. Number one was configuring the backend to AWS specifications, and also configuring the requirements and what was and wasn't allowed with AWS Elastic Beanstalk. The documentation is a little bit sparse, and also it's very much of a trial and error type of thing. So I think having an example and having something with documentation, which is what I tried to do by adding comments and things to my code, is really valuable because it gives people an example, something to work off of, rather than having to dig through a lot of documentation, especially because there isn't that much documentation and there isn't much like supporting resources, like not even many Stack Overflow questions, etc. So this is the Elastic Beanstalk console, and so this is the overview. Nothing is really that interesting over here. I think the most useful sections were the log section, where you can request logs. Usually last 100 lines is pretty good. And this is how I did all of my debugging, which is kind of not very intuitive and not really talked about anywhere, but this was really helpful for me, as well as this configuration section. I think the part where I kind of got stuck the most on was actually configuring this static files software path. So here it shows you where you can add your static files, which is everything you need to load, like HTML, CSS, and like everything else. I think this structure is a little bit unintuitive, and things like this were all things that I noted in my README as kind of like common pitfalls for people to avoid, and I thought that was something that could be really, really useful, especially because I know what I struggled with when I was creating this, and I wanted to make sure there was like a very well laid out process for other people as well. But besides this, there is other things that you can configure, like your EC2 instance. Right now, I'm just using a regular T2 micro instance, but this could be upgraded to like a GPU instance or etc. if there was more intense computation being done, as well as other things to consider, like load balancing and how you want to roll updates and deployments, security, etc. I think all these things are very easy to change, especially because there is this dashboard structure. So I think using Elastic Beanstalk is pretty useful, pretty easy, but make sure you get a good example and make sure you read through a lot of documentation first. The second big part of this project was implementing the visual aids. So there are 4 main changes that we did. Number 1 was adding the heat map. Number 2 were the visual cues and the kind of coloring and design of the website. Number 3 was highlighting changes. And number 4 was the graphs of the adversarial probabilities. So as you can see on the screen, one thing that was really important to us was to be able to show kind of the importance of the different tokens in the sequence. So to show what is most influential in making this original classification and what is most influential in making the adversarial classification. So the larger font sizes are for the top scoring words to show importance. So in this image on the right, you can tell that Israel and conflicts Israel is the most important word, and this obviously corresponds to world news. However, after perturbation, you can see that when Israel is changed to a different I and a different A, then the adversarial class becomes business news. And so this is really important because it can show users kind of a really easy, friendly way for them to get the basic concepts of machine learning, which is ranking and scoring different tokens. Number 2 was the visual cues. So everything on this page is done for a reason. So for the deep word bug algorithm in particular, the model is the most important part. And so to kind of demonstrate this to the user and bring attention to it, we put the choose a model kind of bar up on the top of the screen. So there is a selection bar on the top with the default being model 0, and it kind of stands out to the user and tells them to, hey, first choose a model and then pick the different other options second, because the other options like power, scoring algorithm, and transformer algorithm are not as important as choosing the model. In addition, we use the same colors throughout just so the user could understand and kind of get like a visual flow for the website. And so all of this kind of makes it easier to use, but also kind of goes with the trend of thinking about user design when designing these visualization apps. Because a lot of times I think machine learning and software engineering apps in general don't think much about the user and just think about functionality. But I think for this, we really wanted to focus on what would be easiest for users to understand and what would be the most user-friendly. Number 3 is the colors to highlight the different changes within the original text sample and the adversarial sample. And so this is pretty self-explanatory. The words are highlighted in red or red font if they're different. One of the transformer algorithms is actually deletion. And so when a word is deleted, it's indicated by like a red underscore to show like a space where the letter was deleted. And that's all explained in the index page as well. But this, I think, is really easy way for users to understand the different transformer algorithms and what they do. Number 4 is the graph of the adversarial probabilities. So this is on the bottom of the screen here. This original classification and adversarial classification, not only does it show like which categories were kind of competing for the top classification, but it also shows how much there was a decrease in the original to adversarial classification. So for this Israel news sample, it decreased from 80% being world news to only about 30% being world news. So you can see how much of an impact this deep word bug algorithm had. And so the last thing we did was implementing the code structure. And so for this one, I think This is more for like developers or for coders who are maybe machine learning only or don't have a lot of programming experience. I remember when I first started working with the adversarial playground code, it was similarly structured to a lot of like the web applications I had built before, but it was also a little bit more difficult to understand. And especially when adding in G's code and my front end code, I had to kind of play around with a lot of stuff and check where to add files and stuff like that. And I think the actual process and structure of this web application is really good. And so in theory, it should be very easy for other developers or other coders or other people in Professor Chi's research group to add code to it. And so I think there was a lot of potential here. And so what I really wanted to do was add a lot of comments and examples in the README file and in the other files, and add a lot of explanations just to show that, hey, if you wanted to add and extend this, it should be really easy. Just put your front end files here, put your back end files here, like add a comment here, etc. And then it should be ready to go within like a couple hours, which I think is really useful, especially for Professor Chi's research group where there's a lot of work that can be extended or added onto this. The last thing we did was like with the AWS structure, I also wrote up pretty extensive documentation on that and how I went through that and did the troubleshooting, etc. And so finally, if other additional visualizations were to be added to adversarial playground text, it would just add another tab to the site. And so I think that's like a really good way to aggregate a lot of algorithms, and it's kind of like a one-stop shop for people to see and explore a lot of different things. So finally, I think for future work, there's a lot of really cool and important things that could be done with this. Number one is like adding visualizations for like the other biomedical algorithms. I know deep motif and stuff like that. We're looking a lot at Kipoi, which has a visualization for DNA sequences. And I think kind of having a heat map or indicator for a DNA-like sequence with like a lot of characters, obviously, I think that would be really cool and interesting to see the visualization for that, especially because like genomics and biomedicine algorithms are becoming really popular these days. The second would be to kind of use the work that I've done and the work that other people in this research group have done with AWS Elastic Beanstalk to host other visualizations on AWS, because I think it really is much easier for the users. All they have to do is just click on one link, and they don't have to download anything. They don't have to update their pip. They don't have to update like PyTorch and stuff like that. They don't have to like check with all the versions, especially if like a new version of TensorFlow comes out. I think it is much easier to host something on AWS because it just takes care of everything for you. And finally, there were a lot of features that I thought would be really cool for this, but just either didn't have time to implement or just didn't get around to it. And those are kind of like, number one, automatically interfacing with the deep workbook algorithm to add updates from the backend. So kind of connecting those two, and to increase the complexity of the heat map and the tokens to kind of do it based on the complexity of the sentence. So if somebody inputted a whole paragraph, then maybe we want to display like the top 5 or 10 tokens instead of just the top 2 tokens. I think there's a lot of potential for work in this, and there's always more ways to make visualizations more effective, more user-friendly, and more helpful in general. And so overall, I had a lot of fun working on this project and with Professor Chi and with G. And I hope you guys can try it out. All of this will be linked in the Deep Workbook GitHub in a subfolder. And also, I'm sure Professor Chi can send out the link. But I hope everybody can take a look and play around with it and have fun.